There is a noise. I don't think from off air. Okay. BT. Fan noise. Is it okay now? Okay. So let us continue our yesterday's session, communication. So today we'll start with message passing. So no, properly. Fine, let me use. Like all other IPC mechanism, this message passing is also implemented by two ways. One is called as system V or system 5. Okay, so system 5 IPC, and another way is making use of POSIX. So POSIX, Q, and V message queues. So two different implementations are there. Okay. I'll continue with system 5 message queues. Okay. We'll see what are different calls required, what are different steps are there in order to make use of message passing library, and to arrange those, and maybe we'll go with one of the sample example for definitely there will be one assignment on inter-process communication. So maybe by making use of pipes, unnamed, both we saw. Then shared memory also we covered yesterday. Today we'll see the message passing. Semaphores part we have already finished. Okay, so possibly inter-process synchronization, one assignment will be there, and inter-process communication, or two assignments will be there. Okay, lab assignments, and of course you can go with any of the programming language, absolutely no problem. But mostly I'm discussing the functions or library functions for inter-process communication from C and C++. But you use it from say, for example, Python, you can continue because similar kind of stuff is there, or else you can just continue with C++, no problem. Okay. So system 5 message queue, we already know that the message queues will be created in the kernel space. Just assume something like this is the total memory, and this door part is, say, for example, kernel, and maybe we have something like this is one process, and say this is another. So let me call this as, this is process 1. For example, this is process 2, and now this is the kernel space. So let me here kernel space, right? So this is the kernel space for, that is process and process 2 is separate, kernel space is separate. Okay, so what happens is the message queue will be created here, and in this queue multiple messages are stored. So for example, this is message 1, okay, something like this. This could be second one. So multiple messages will be stored in that. Okay, so whenever any process want to communicate, that process will put the message. For example, process 1 want to communicate with process 2, so process 1 will store message in the message queue, something like this. Okay, I guess I have taken highlighter. What is it? Okay, no problem. So this, like, P1 will put message in the queue, and now whenever P2 want to read it, yes, P2 will again read something like this, right? Now only problem with this approach is the things we need to copy from the space of process to the kernel space, it need to be copied twice. So in order for that task, it needs more time. So the message from P1 to P2 first of all goes to P1 to space, and then from kernel space to P2. So it is not directly from P1 to P2. Okay, it takes some time. So buffer management is required. Okay, and whatever the data we encode into the message, that is basically called as marshalling and demarshalling. That part we need to do 2 times for a single message. So that is the only overhead required here. Okay, so given this, let us see what are the different calls we need for implementing CAs. Okay, so because this is system 5 IPC or system V IPC, IPC.h, that header file is required. So that is available in slash IPC.h. So this is the one of the header file which you need to include, and another one is sys slash msg.h. Now this is for the message. The message passing libraries are there. Okay, so 2 header files are required. That is one thing. I think theoretically we have already discussed about what are the different designs of making use of message passing or message queues, whether the direct naming is there. Direct, we already saw that whenever we want to send a message from P1 to P2, in that case, we need to mention the process ID of P2, and most of the time in modern operating systems, these process IDs are created dynamically at runtime. So that is difficult to implement, rather I can say. So mailbox kind of thing is implemented. But with system 5 message queues, anyways, we'll see how it is implemented. Okay, like for example, if the message queue is shared between say 5 processes and P1 wants message to P3, okay, how that is managed, that we need to see. For that, actually there is something called a message type field separate available there. So that anyways we'll discuss. Next important part is whether the message should be of same size, of fixed size, or of dynamic size. Right? Now in system 5 message queue, we need to declare one structure to specify the, so it is something like struct, say for example my MSG, so my message we want to send, and is of dynamic size, the is must, and that is the message type. Let me call it as a yum type. So this is message type. It must be long integer. Struct my MSG. So I am actually declaring one structure which is used to hold the message data. The compulsory part, this is the must part. It must be long. Name you can give anything, no problem. So, but it must be of type long integer. And second one, you can specify whatever data, maybe it is character, long, integer, double, another structure, it could be anything. Okay. So maybe for example, I want to send something like half KB of message. So maybe a character denotes 1 byte. So I declare array character data of something like this. So this will be actual my message data, right? This is something like this. And as I mentioned, only first structure member is mandatory of type long. After that, you can give anything. For example, I want to send the details of book. Second member will be book. Where in struct book, maybe I declare something like struct book, character, title, author, publication, number of pages, whatever. So that is anyways user defined structure, right? Or you can embed those members here. It is not restricted to just 2 members. Only thing is the convention says the first member is mandatory with the data type long integer. So that is used to denote the message type. Anyways, see for what purpose this message type is required. So I can say step number 1 is you need to declare or include the header files. So this is step number 1, include the header file. Then step number 2 is you need to declare your message. Whether, say for example, maybe it is something like I want 2 numbers to the one process, and it will give me result of that, maybe some sort of multiplication of both those 2 numbers, something like that. So in that case, first of all, I need to specify long M type, that is one compulsory, and then it could be something like integer number 1 comma number 2. So 2 numbers I want to send. So two numbers, and maybe the process who is actually giving result of that may declare something like struct result, something like that, struct result, where again must that because that is used for actual communication. Okay, so anyways, that we'll see. So now what I'll do is, let me try to go. Yes, no problem. Okay, let me rewrite. Mention is the header files. Step 2 I mentioned is message type, or rather I can say message structure. You need to define the message structure. Okay, now this, what you need, step number 3, let me put it here. Step number 3, you need to create the message queue. Create, let me put it in short, MSQ. That is message queue. You need to create message queue, and for that, if we want to see details of this, creating the message queue, then MSG get is the library function used from the header file msg.h. Okay, two parameters are required for this. One is the key, and yesterday we saw how to create this key. We have used something called as f2k. That function we have used yesterday. So similar kind of thing, you need to create the key. And what is use of this key is, maybe kernel will have multiple message queues. Kernel may have multiple. In that case, in order to uniquely identify with which message queue you want to deal, that will be uniquely identified the key. Note that two processes want to communicate with each other through message queue, then both should refer to the same message queue. So same key must be used by both. Okay, so this one is required. And second one is the access permissions. And then if first time you are creating it, it must be something like 0666 or there. Now don't call it as a pipe, it is or, rather or symbol in C language, IPC create. So if message queue with specified key is already there, and this key could be, as I already mentioned, it could be anything. Say for example, either you use with F2K, or you can directly use some number, something like 1 2 3 4 or whatever number. But the best practice is to make F2K. Okay. Return by this is the queue ID. It returns queue ID, or rather I can say message queue ID. So queue ID. So typically it is something like this. Queue ID is equal to msggate specify key. I would ask one question here. Do you know about these permissions? Because that is actually important. So whatever the permissions mentioned here, 0666, it whatever the file system you have under Linux, similar kind of permissions are there: read, write, execute. Okay, this is number. Okay. So same thing use here. So step number is create the message queue. Now if queue is already available with the same key, you will just get access permission to that, right? And if Q is not there, the flag IPC underscore create will create a and Q ID will be given to you. Okay, so that is how it works. So Q ID is equal to MS create key and permissions and then IPC create, right? Now next part is where you want to send the message. What I'll do is maybe I'll write that as step number step 4. You haven't shared the screen. Whiteboard is there. How but I am actually writing on whiteboard. Is it not visible? Yes, somebody. There is a delay. No, I'm got confused. Or reply now. To see the content properly. Let me open poll. Just a minute. Just a minute. Just respond there, please. I guess. Or somebody saying need to scroll maybe because second page. So what I'll do is I'll close this whiteboard and I'll open new one so that no scrolling. Okay. So let me close this. Okay. Can you see the terminal? Okay, fine. Okay, fine. So let me open it here. Man msg get I think it is not installed here. No. Let me open browser. So for me, share my screen. Just a minute. Okay. So see here. This is the key. And flag I mentioned right now are, one is I mentioned 0666, XOR it with IPC underscore create. So even those other flags are also there, like IPC private. Whenever you want to specify private, then your queue will not be shared between other processes. Related processes can use it. Even multiple threads can use it. Okay. So this is related to MSG get, and which returns one integer, and that is the queue ID. Fine. So it gives you the queue ID. Now let us go back to the terminal. Fine. Now next thing is, whenever you want to send the message, a better option what we'll do is, let me open CD documents and CD desktop and OS1, and let me use VIM. MSG. I have one program there, MSG send. So for example, here on this screen, if you see, this is my message. Okay. I use structure. So struct my message, long int my message type, and character data of say 1 KB. So I think this is step number 2. Then created the message queue here. What I did is, you can observe it here. For example, yesterday key use of F2K. Here I am doing 1, 2, 3, 4. So that is the key I am using here. And because I need to typecast it. Why? The very first parameter required by MSG get is of type key underscore T. So is integer. So I'm just typecasting it, right? Now next step is to send the message. For that, see, this is the call there. So MSG SND, not SEND, MSG SND. So this send the message. Now where you want to send the message? Remember, before sending message, you must first of all create the message. That part is important. We create the message. Okay. So create message pass. Now in my structure, there are just two members. One is message type and one is actual data. Okay. So what I'm doing here is I create one buffer, a normal buffer of character data, and I use fgetS. So fgetS is used to read the string from standard input device. So fgetS buffer 1024 and stdin I mentioned there. So standard input device up to 1K size, 1 KB, and message type I selected is 1 because that is of type long integer. Now how to utilize this we'll definitely see. Now this is used to create the message to pass to the message queue and then make MSG send. Now as expected, MSG send will take very first parameter is the queue ID. Okay, so that is the message queue ID is actually returned by MSG get, right, in step number 3. Second thing is, now I do a variable called as A. If you can see on the screen, it here. Okay, A is there. So struct my message A. So A is a variable of type struct my message, and I set first parameter A dot my message type is equal to 1, and A dot data I am copying it with buffer. And because that is a character array, you directly cannot make use of assignment. Otherwise, it will just copy the pointer. That creates a problem. So I use strcpy because anyways character is nothing but a string. And in order to copy the string, you simply go with strcpy. Okay, that means I'll pass the address of A, which is message, and typecast to void star. That means can utilize with any type of data. Only thing is its first parameter must be of type long. Then how many bytes are there? Yes, message will contain 1024 max. So the third parameter is size, message size, and last parameter is flag, which I set it to 0. Fourth parameter, that is a flag that can be utilized for non-blocking call also. For example, there is something called as a IPC no wait. Let me type it here. It is coming from that IPC header file. While creating the queue, if suppose that queue is full, even though we have not mentioned some sort for that, operating system employs some limit. Anyways, you can limits, IPC limits. In that case, until and unless there is no space, it will be blocked. Better option is keep 0, so it will be blocked. And if you don't want to block your process for that, you can make use of IPC no wait. In that case, MSG send will come back with error, right? And now remember, I am putting everything in this while loop. So until and unless user won't type ENT, it will be, so it is like an infinite loop kind of a thing. So until you give end. So if you type, for example, end, then the value of this variable becomes 0, right? And once this becomes 0, while running become false, and you come out of that. So because this is a process, I am not doing anything other than sending. I'm just sending it. At the end, rather I can say the last step is to remove the queue. This is used to remove the queue. MSGCTL, like SHMCTL we saw for shared memory. So there is some sort of naming uniformities in order to create the QMSG gate. Now in case of shared memory, it was SHM gate, right? MSG message QID is the first parameter. IPC RMID, that is the command, and flags are set to 0. Where meaning of IPC RMID is delete the queue. Now just one part is remaining here, and that is MSG RCV. So what I'll do is, let me come out of this. This is the program for message receiver. Same steps. Step number 1 is include the header files. Add these steps again. So this is step number 1. Include the header files. Step number 2, create the message structure. Step number 3, create the message queue. Then now suppose here we want to read it. So the function used to read the message from message queue is MSG RCV. Yes, check this one. MSG RCV. Almost exactly same like send, except one parameter is message to receive. This one. Message to receive. And here you need to mention the type message. This is the most important, because if my message queue has multiple types of messages, say while sending it type, right? So for example, in the send program, we set it to 1. If you observe it here, making use of 0 here, message to receive is 0. See here, MSG to receive is equal to 0. Okay. Now a small trick is there on receiving the dependent type. There are 3 possibilities for that. First is the message type is equal to 0. Meaning of that is the first message in the queue is irrespective of its type. Let me type it here so that it will be clear. Type is equal to 0. Read first message. Okay. If this type is equal to any positive number, so that definitely it is greater than 0. If it is any positive number, that means if the type to read is greater than 0, first message type equal to whatever type you mention. type. If you have a message queue in which 5 messages are there and message type 3, there are 2 messages. Say first message is with message type 1, second message is message type 3, third message is again 4, fourth message is with message type 3. There are 2 messages with message type 3. Then it will read the first one which arrived first. Okay, so that is what the meaning of type is equal to positive. Okay, so that is one more. If the type of this message is equal to negative number, if the type of this message is some negative number, okay, in that case, then the first message, Mansi Sonavne, please, Mansi, mute yourself. Okay, if type is negative, then the first message in the queue with message type less than or equal to absolute value you provided. Less than and equal to absolute value is typically given something like this. Something like this. So first message whose type is less than or equal to value of type you mentioned. So for example, let me tell you, for example, if I mention something like -3, suppose there are message queue with the value something like some text box there. Suppose in message queue I have something like 3, then 7, then 3, 7, 8, something like this. Okay, or maybe 9, 10, something like this. So my message queue has 4 messages with type 3, 7, 9, and 10. And suppose the message type I want to read is equal to so the MSU function specifies that read the message with type. So message to receive here, you can see it here, message to receive. If the value of that is -8, then absolute value of -8 is 8, and it will try to read the first message in the queue whose value is less than. So definitely less than that, right? Now suppose if I modify this 3 to say 23, first message is 23, then 7, then 9, and then 10. And if my message to read is -8, then what happens is absolute value of this is 8. So the first message whose than or equal to 8 will be read. So 23 will not be read. 7, yes, it will be read because 7 is less than absolute value of -8. Okay. If it is positive, for example, if I specify message type is equal to 9, now that is simple thing. When I mention it as a 9, read the first message which will match with 9. Why I am saying first message, reason behind that is maybe after 10 also there is another message with type 9. So 23 will not be read, 7 will not be read, 9 will be read. No problem, because that is the first message which gets match with. Okay? And if this message is equal to 0, it will don't compare it with message queue. It will simply read the first message, whatever the type is. Say for example here it is 20. It simply read 20. Got it? Is that okay? Now the same trick is here. Here I mentioned this as a 0. That means I the first message. Whenever the message received will just printf, and if that side sends end, again check that I'm making use of strncmp. So just 3 bytes I want to compare. I'll set running equal to 0 and it will start. Okay, that is how it works. Once running is equal to 0, will come out of this loop, and inside of this loop will simply delete the message queue. You, for example, sender is there, and if sender deletes the message queue, what happens at a receiver side? Always remember, even that happens with your normal file also. Whenever you delete a file, what happens is reference count is decremented. For example, if 4 processes are there, 4 are sharing the same message queue, and if one of the process deletes the message queue, reference count is decremented. So 4 reference count becomes 3, 3 becomes 2, 2 becomes 1. Once it becomes 0, then it is actually deleted from your system. So no need to worry regarding this. Okay. So now what I'll do is, let us try to compare both the programs. I don't know if it works on Mac or not. Let me just try it. So, for example, GCC hyper sender msg send.c, it got compiled, and say receiver underscore receive.c. Hyphen o I use because both the programs are same folder. Now, because this is in infinite loop, what I'll do is I'll open one more tab for the same. Fine. Where I'm working, it is OS1 folder. Let me check. OS1. So in one, even before that, can you see both the tabs? Somebody can please respond. Both the tabs of my terminal. Okay, fine. Or rather, what I'll do, anyways, I shared screen. So what I'll do is I'll open another window and say new window and resize it so till the effect here. And here what I'll do is, let me close this now and let me resize this also. And here I want to now execute the receiver. Let me check working directory. I need to go to OS1 folder. Okay. And here I want to run receiver program. And here I want to run the sender program. Now, two different processes are there. One is sender process and one is receiver process. Sender is trying to read from the terminal. See, now I execute send as well as receiver. Sender says enter some text. I just given hi. Message hi. Anyway, I am just dealing with string, and this is infinite loop till I enter end. Okay, something like you. Anyways, you can send anything. I'm using page queues for communication. Okay, and if I type, this will be terminated because that condition I check. So once I type end, remember sender is also terminated and is also terminated. Fine. Similarly, you can look for the information of POSIX messages. So I'll leave it to you for self-study. Okay. So either part I'll explain and remaining part you need to do on your own. Do you have doubts regarding this? Let me see the chat box. Can you see the messages? See both the. Okay, fine. Even there, no problem. You got the idea? How two processes can communicate with each other, making use of doubt. See, there is one more command called IPCS. Now, anyway, actually I deleted, no problem. But what I'll do is, say for example, let me clear this and let me execute sender again. And now here I'll check for IPCS. Here that there is one message queue here. Can you see that? This one. IPCS is the command that displays what are different IPC mechanisms right now active in the system. You'll find there is a semaphore already there, and there is a message queue right now. So for a terminate this program, see message queue is removed. Okay. So you work with IPCS, and this command is also available on Linux. Let me stop sharing. Okay, there is one question from Aditya. For Python, which are there, same or different? Python almost same. So let me check it. Python. There in case of a Python, there is one package called as IPCQ and POSIX MQ. Let me type POSIX MQ. Stands for POSIX message queue. POSIX message queue. So so you can use different functions from that package. Okay. Java, I don't know. Java, you need to check. C++, same thing is available, no problem. C and C++ both are having common libraries. Any doubt in this? Fine. So we'll stop here.